Hello everyone, welcome to our new video. This is Introduction to Pvsyst second video, and in this video I'm very happy that we will launch our first project. We will start to use the actual interface of the Pvsyst, and as our first project we will try to deal with two tilted rooftop systems. And for that video we will just focus on the orientation part of the project. And in order to understand the orientation part, when we are dealing with the orientation part, we will encounter some related technical terms. And as we move forward, as we encounter with that terms, I will try to explain the meaning of it so that it will be more helpful, more understandable for all of us to comprehend the overall system in a more clear way. Let's start if you want without delay. For our two tilted rooftop system, it will be grid connected. For the meanings of the grid connected standalone pumping project, and also how we can make a differentiation between what are the differences between grid connected and standalone systems is explained in our first introduction to Pvsyst lecture. If you want to learn that points, you can watch the first video. For our first project, we will go with the grid connected system. Our project or system will be connected to the grid. Let's click into grid connected. As you can see, when we click the grid connected, standalone or pumping, a type of a project, a new page pop up. But sometimes we can encounter with another project that we previously opened in the Pvsyst. In order to prevent that situation, we can just click the new. And when we click the new project screen will pop up. For our project name, we can just enter two tilted rooftop system. And in order to indicating this is our first project, we can write first project. Yes. And after giving it a name, we should add the meteo file. In order to add meteo file, we should click that button. And after we clicking, it says, please wait, updating geographical data. As you can see, this is the Earth map. And there is a label called locality. In the locality section, we will enter the latitude and longitude details of our location. But when we will enter the latitude and longitude details, and after we enter that specific latitude and longitude details, the Pvsyst will automatically find that place, go that location, and it will show us some meteorological data about that location. But how we will find the latitude and longitude of our place where we want to construct our project, for that we will benefit from Google Earth. When I click Google Earth, as you see, this is the main interface of the Google Earth. And in order to find the place where we want to go, we should go to the search section, and into the search section label, there's a two option. One way is to writing the name of the place where we want to go, or writing latitude and longitude details of the place where we want to go. Since we don't know the latitude and longitude and we want to know, we should surely just write the name of the place. And for that project, I choose the Turkey as a location in the city of the Adana. And the place where we build, the roof where we construct our system will be the roof of the 3 Dağ plastic. When I click the enter, it goes directly to the place. As you can see, I will bring it closer so that we can see clearly. Yes. And as you can see, this is the roof of the 3 plastic where we construct our system. But in order to understand the roof clearly and in order to make the forward calculations in a more clear way, in a better way, we should adjust the position of the roof, position of the building on the screen of the Google Earth, as if we are looking from a bird eye view, just like that, as if we are looking from a bird eye view, from the top of it. And after that, in order to find latitude and longitude, we can just click that yellow pin. And after that, it says at new place mark. I will give a name for the location, for example, 2 tilted, as we say 2 tilted rooftop. In a parenthesis, we will say 3 dağ. 3 dağ. Okay. 3 dağ plastic. And as you can see, the latitude and longitude details appear on the screen, show on the screen. I can copy these latitudes and paste it to the locality section of the Pvsyst, but when I click OK, without doing that, when I click OK, as you can see, the 2 tilted rooftop 3 dağ name and the place mark is popped up in my places section. What that means is when I close the Google Earth and reopen it, if I want to go to that place, I will go to my place. Since it saves that location, I will go to my places and choose the name of the place where I want to go again. For example, click the 2 tilted rooftop 3 dağ and I will go that location automatically. It saves the location. And to take the latitude and longitude, make right click to a yellow pin and choose properties. From that, copy the latitude and paste it to the Pvsyst, and click the tab. Left a space, and after that, copy to longitude and paste it to the Pvsyst again and click search. After we click search, just like in the Google Earth, the Pvsyst automatically find and go the place. It says, as you can see, it says Adana. I'm in the right location. This is the location where we add a place mark in the Google Earth, and I say accept the selected point. But before accepting the selecting point, in order to verify that it is the exact location where I want to go, as you can see, this is exactly the latitude and longitude details. Latitude and longitude details. This latitude detail, this 360.98 blah blah blah, and longitude details 35.64 blah blah is exactly matching with the latitude and longitude of the locality section. And after that, after verifying it, it is just for verification, I can click the accept selected point. After that, as you can see, it says please import the monthly meteo data from Meteonorm or NASA or Pvsyst or ENRI-EL. You can think these names, this Meteonorm, NASA, Pvsyst, like the sites, these are the sites where we can import the meteorological data of the place where we want to construct our system. For that, I just randomly click import. And after I click import, it brings me to the global horizontal irradiation, horizontal diffuse irradiation, temperature, and some humidity details of the location that I enter, that I import to the system. According to the months for the January, February, March, and etc. to the December. For example, for the global horizontal irradiation, it says for a year, it is approximately the 1713 kilowatt hour per square meter. For a year, it is 1713 kilowatt hour per square meter. And there is also another terms linked with turbidity, relative humidity, and the details like that. And also it says roughly the approximate temperature that we attain throughout the year can be 19.1 Celsius degree. I mean, between that labels, between the wind velocity, temperature, or link turbidity, global horizontal irradiation, the most important label, the heading that we have to learn is global horizontal irradiation. Let's try to learn what is global horizontal irradiation. Actually, when we are talking about the just as the term irradiation, we can think like it is the amount of the sunlight that comes to the surface of an object. But when we are considering the global horizontal irradiation, it is composed of three separate sub components or three sub constituents. And we can say these constituents as direct normal irradiance, diffuse horizontal irradiance, and ground reflected radiation. This is the three main components in the global horizontal irradiation, we can say. And let's try to explain the first component, the direct normal irradiance. What is direct normal irradiance? As you can see from the picture right below, the direct normal irradiance is the amount of the sunlight that comes directly to the surface of the earth. In our case, to the surface of the panel, the amount of the sunlight that comes directly to the surface of the panel. And another term, it is called beam radiation, as you can see in the picture, beam radiation. The sunlight is directly coming to the surface of the panel. But contrary to that, for the diffuse horizontal irradiation, for the second component of the global horizontal irradiation, direct horizontal irradiation, the diffuse horizontal irradiation can be defined is the sunlight, as we write. It is the sunlight that is scattered by some atmospheric constituents, such as clouds. But what I mean with that sentence? I mean, for the diffuse horizontal irradiation, the sunlight is not coming directly to the surface of the panel, just like in the beam radiation. It is not going like that. I mean, firstly, the sunlights firstly visit some atmospheric constituents in order to understand better, we can give example as clouds. The sunlight firstly visit the clouds, and some of the sunlight that comes to the clouds will be reflected to the place where it comes, and some of the sunlight, as you can see from the picture, some of the sunlight is diffused through the surface of the ground, in our case surface of the panel, as you see. And this is called diffuse horizontal irradiation. It is not direct because the sunlight first visit a atmospheric constituent, and then secondly visit the surface of the earth, the surface of the panel in our case. And the third important how can I say, the component of the global horizontal irradiance is the ground reflected radiation. Again, we can see from the picture some amount of sunlight. As we can understand from its name, it says ground reflected radiation. Some amount of the sunlight comes to the ground. For example, with the grounds, what we mean is to the seas, to the oceans, to the sands, some amount of sunlight coming to that places, coming to that type of grounds. and it is reflected from the seas, ocean, and sands. And as you can see, when the sun comes to, for example, for that picture, we can think that place like sand, or this place as it writes as it writes like sea. When some sunlight is coming to the ground, when it is reflected, there is a possibility that some of the sunlight will coincide with the surface of the panel. When the sunlight is coming to the surface of the ground, such as surface of the sea, surface of the sand, surface of the ocean, when the sunlight comes and reflected to the place, in this travel, we can call it like travel. In this travel, there is a possibility that some amount of sunlight will coincide with the surface of the panel, and this is called ground reflected radiation. And for the ground reflected radiation, I mean for the occurrence of the ground reflected irradiation, the main sense behind for the occurrence of it is the albedo effect. What is albedo effect? Albedo is the measure of how much sunlight or solar radiation is reflected by a surface instead of being absorbing it. As we try to understood, we said that some of the sunlight is reflected from the ground, reflected to the place where it comes. And the albedo is the amount of the sunlight that is being reflected from a surface instead of being absorbed. I mean, thanks to the albedo effect, ground reflected radiation occurs and some of the sunlight coincide with the surface of the panel. Some of the sunlight comes to the surface of the panel. And also we can give a little how can I say, information. The albedo effect is generally represented as a percentage. For example, as far as I remember, the albedo effect of the sea and oceans are not so much high. I mean, they are mostly absorbing the light that comes to their surface. But for the clouds, their albedo effect, I mean the expressed percentage of their albedo is high, which means they reflect most of the sunlight that comes to the surface of it. The most of the sunlight is reflected, and a little amount of the sunlight that comes to the surface of the cloud is being absorbed. And after we learn that section, we can continue. This was the most important part. Global horizontal irradiation is important. And we should say, what is the unit of it? The unit of it is kilowatt hour per meter square. And it can be per year, per month, and it can be derived like that. But kilowatt hour per meter square is important. How much sunlight is coming to the coming per meter square in a specified time. This is the important, like that. It is the kilowatt hour per meter square, and it says it's approximately that much, and I can click OK. It says, do you want to overwrite it? Yakapınar already exists. Do you want to overwrite it? I can click yes. The geographical site file is now saved in the database. I click OK, yes. Yes, I want to save it. And after clicking that, I again click the saving. And now we are done with the meteo file part. After importing the meteo data file, just we do. After doing the orientation part, after doing the system part, after doing the horizontal and near shadings part, after every part, every section, we should click the save button. After we click the save button, the new labels will be open. And it was just the parts, I mean the meteo parts, meteo file parts, before moving forward with the orientation. In another video, I mean in the upcoming video, we will continue with the orientation part. Thank you very much for listening to me. See you again.